Okay, question 4. Now, Sam is pulling a box and Peter is pushing the box. So when you read the question, Peter is pushing. Pushing means away from you, pulling towards you. So basically, Peter is pushing, Sam is pulling. And the forces for Sam, so Sam pulls with 50 newtons, Peter push with 70 newtons. Now remember, when we are looking at calculating net forces, we only look at the direction of the arrowhead. So you look at this arrowhead, it is pointing to the left. This arrowhead is also pointing to the left, right? So this is your left, this is your right. So what is the net force? So if you exert a force 70 newtons to the left, you also exert a force 50 newtons to the left, you just add them together, 50 plus 70, and you get 120. And of course, since both of them are exerting the force to the left, the net force will be to the left. So after a while, Peter changed the way you exert the force, and then you find that there is zero net force. Zero net force means that the forces are balanced. Okay, so what is the meaning of forces are balanced? That means the forces acting to the left and to the right are the same. So what could Peter have done? Well, the box is here. So Sam is still pulling it with 50 newtons. So what Peter could have done is Peter might have, instead of pushing, might be pulling it towards himself. So 50 newtons, 50 newtons, and then in this case, the net force becomes 0. So suggest, what did Peter do? Peter pulled the box with 50 newtons force. Okay, so you're actually pulling. Just now they say Peter is pushing, right? So if Peter is pulling instead, then the net force will be 0. Okay, last question. Now, a student dropped a tennis ball from a height. Remember, if you are dropping something downwards, okay? So when you are dropping something downwards, the energy conversion for a downward motion is from GPE to KE. So if you're going up, then it's from KE to GPE. So now, because you're dropping it downwards, then it's gravitational. Sorry, I should have given you more space. Gravitational potential energy is converted to kinetic energy. And once the ball hits the ground, just like this, okay, if I have something here and I drop it, you will hear a sound, right? So now in this case is a ball, so the ball actually is compressed and then it bounces up again. So when you compress a ball, anything that you can compress or you can stretch, it will have elastic potential energy. If you do not write potential, you just put elastic, then no marks. Okay, you must show me that it's elastic. You must show that it's a stored energy, so potential. So when the ball hits the ground, some energy is lost. So remember, when you drop anything, there will also always be some sound coming out, so that's lost. And when you drop something, you hit the ground, some heat energy, thermal energy is also being lost. Okay, any form of collision, knocking, the thermal energy will be will be lost. Sorry, energy will be lost as thermal energy. Okay, so you have come to the end of the paper. Thank you for your cooperation in doing the corrections. All right, and all the best for your next quiz.